Where is my presentation? Do you see my presentation?
Yes, not yes. Presentation mode, but yeah, we see the slides.
Is it okay or?
No, yeah. Now is in presentation
yes,
mode.
Yes, that's fine. Thanks.
Okay, I can start now. So I will present some tools related to fate of chemicals in the environment. And this presentation will focus on risk assessment of chemical released in surface waters. So just some indication about the history of this tool. The Merlin Expo tool results from two European projects, 2FUN and 4FUN. And in the Life VERMEER project, we merge this Merlin Expo tool with the VEGA tool to give life to the Life VERMEER tools. So what were the objectives of our works? At the beginning of these European projects. Actually, the objective was to integrate in a common software a library of models simulating the fate of chemicals in the environment and in human body. So what we did was to integrate models dedicated to the transport of chemicals in the environment. So we assume here that we release chemicals in surface waters, for example, but also in the atmosphere in a region of the assessment. So the first objective was to develop multimedia models simulating the fate of chemicals in some media of concern for human consumption, for example, like drinking water, milk, fish, etc. These multimedia models were combined with exposure behavior models, so ingestion of food, etc. And at the end of this process, we could estimate external exposure expressed, for example, in milligram of chemical ingested per day and per kilogram body. This external exposure can be combined with pharmacokinetic models simulating the fate of chemicals in human body. And so at the end of this process, it was possible to simulate the concentration of chemicals in several human organs. These models can be used also for environmental exposure assessment here, described in the red circle. So we can simulate the transfer of chemical in an aquatic trophic web, simulating, for example, a transfer in phytoplankton, invertebrates, fish, and aquatic mammals. So today I will dedicate my presentation on this specific part of the tool, even if there are other tools simulating other media in the environment. So first, short presentation of the models which are included in the tool for simulating the fate of chemical in rivers and in aquatic food webs. In the tool, there is a model simulating the fate of chemicals in rivers, simulating, for example, the processes of absorption, desorption of chemicals between water and suspended matter, deposition and resuspension between overlying water and sediments, and diffusion of chemicals between pore water, sediment pore water, and overlying water. We have also developed a model simulating the fate of chemical in invertebrates and in fish, simulating, for example, the uptake of chemicals through the respiratory system. and through the gastrointestinal tract system. We simulate also the dilution of chemicals through growth and metabolism in organisms. And finally, you can also use models simulating the fate of chemicals in mammals, for example, aquatic mammals. This is a simplified pharmacokinetic models taking into account organs which are of concern for example, for fish, for human consumption. So you simulate here the transfer of chemicals in the gastrointestinal system, the diffusion from gastrointestinal system to blood, and finally the transfer of chemicals in different organs through the blood circulation of organs and the partition between lipids and water in each organ. You can take also into account loss processes like metabolism, excretion, or urinary elimination. If you want, you can combine this model with the human pharmacokinetic model. For example, if in your scenario you assume that some human population consume fish or invertebrates, so in the Merlin Expo tool, there is a model for describing the human body in detail and the distribution of chemicals within this body. So there are two routes of administration, inhalation and ingestion. The substance is distributed in 23 tissues. There are different sites for metabolisms and elimination. So all these models can be found in the Merlin Expo library. You have here the list of models that are available in this library, and you can choose any model to build your own scenario. So for example, if you want to build a scenario related to releases of chemicals in a river, you can use the model related to the fate of chemicals in river, phytoplankton, invertebrates, fish, and mammals. And you can build the connections between all these models, so the prey-predator relationships, for example. All these models are described in detailed materials. So in the Merlin Expo website, you can download the description of each model, so river, fish, etc. So all these models are described in detail on their mathematical point of view, scientific background, parameter values, etc. And we have also prepared some models tutorial in the Merlin Expo website to facilitate the transfer to end users. So this was the starting point of the Life VERMEER project. And during the Life VERMEER project, we have improved this Merlin Expo tool. So first improvement. You can easily imagine that all these models are based on a great quantity of parameters like partition coefficients, half-lives in different media, in water, in organisms, bioconcentration factors, etc., etc. And the problem is to find the good values for all these parameters and for a large range of chemicals. This is also the case for pharmacokinetic models, where you have to assume some default values for blood tissue partition coefficient, diffusion rates, etc. So we used the potential of the VEGA tools for finding a solution for this problem. Indeed, the VEGA is a library of QSAR models, and these QSAR models are able to generate parameter values from databases and from different QSAR models with uncertainty margin. So all the parameter values can now be directly generated by VEGA through an automatic combination between the two tools. So concretely, how does it work? For example, here you have a parameter, but bias concentration factor for a given substance. This is a rodenticide here, and when you open the tool, you have an empty cell here. So that means that you have to inform this cell to give a value for this parameter value. In this case, you can call VEGA directly, and VEGA will find the right model for bioconcentration factor. VEGA model will run and will return a value for the requested parameter. And now the parameter value is available, and you can run the Merlin Expo tool. Second improvement. The advantage of the Merlin Expo tool is its flexibility, because considering all the models that are available in the library, you can build a very complex scenario taking into account releases in water or in the atmosphere, and all the relationship between the different environmental media. But obviously, flexibility is also difficult to cope, because you have to define yourself the scenario, the parameter values, etc. And some end users may be afraid of this freedom. So we have decided to propose predefined scenario for some case studies. That means that the relevant models are already selected and connected in line with regulatory recommendations, and that means also that we propose default values for the majority of parameters. Only a small number of parameters have to be informed by end users, because obviously we can't define a generic value for depth of the river or for rainfall, for meteorological data, etc. So we can say that 95% of the scenario building work is already done. What you have to do is to inform your own site-specific data. So we have prepared a predefined scenario for 6 case studies: rodenticides, solvents, metals, food contact materials, dispersants, and oil. And for the 3 first case study, rodenticides, solvents, and metals, these predefined scenario are based on the assumption that these chemicals are released in surface waters, in rivers, for example. The third improvement that we worked on during the VERMEER project was to combine exposure and hazard. At the beginning of the project, Merlin Expo was a tool dedicated to exposure and only exposure. Now, thanks to VEGA, to the combination with VEGA, we can combine exposure and hazard, because we can call VEGA models to include them in the Merlin Expo tools, and to propose a risk assessment tool. This is now the live VERMEER tools. So I will now illustrate this with one example. So the VERMEER rodenticide tool. The starting point of this case study was the regulatory context. So there is a document published by ECHA related to emission scenario of rodenticides in different media. And in particular, there is a chapter dedicated to exposure scenarios for bank slopes, so for the release of rodenticides in the surface waters. And in this case, the main question, the main issue was the secondary poisoning. So what is the risk of contamination to fish and aquatic mammals, for example? So the VERMEER rodenticide tool was designed to be fully aligned with this ECA scenario and approach. So we have prepared this predefined exposure scenario, including different models from the Merlin Expo library, so the river, phytoplankton, invertebrates, fish, and mammals models. From that, we have also predefined generic food web, selecting different typical organisms like phytoplankton, pelagic invertebrates and benthic invertebrates, and 4 typical fish species. For example, small pelagic, small benthopelagic, small carnivorous, and big carnivorous species. And you can see the different relationships between all these species and also the relationship with the sediment. With this predefined scenario, you can run simulation, and I show here some examples of results. We have run this scenario with different rodenticide, for example, Brodifacoum, and you can simulate the concentration of this rodenticide in different fish species and in also mammal species, in this case otter, considering a direct input, so an input during 1 day and 0 after this direct input. From this simulation, you can also rank rodenticide according to their exposure potential. So you can calculate the area under the curve. Here, for example, you consider this curve here. You calculate the area under the curve, and you can rank the different rodenticides according to their potential for exposure with uncertainty range. What we did also, we ran a reverse modeling exercise. So we start from monitoring data of rodenticides in fish, and from these fish levels, we ran reverse modeling, and we estimate the mean rodenticides concentration in water. And we obtain estimated concentration in water, which can be compared to hazard prediction predicted by VEGA. So we have also prepared some predefined scenario for solvents. So the model is parameterized for more than 300 solvents, and with this tool we are now working for ranking different solvents according to different criteria regarding exposure and hazard. And we have also in our VERMEER tool specific model for a specific tool for metals released in aquatic systems. In this case, we have added a specific model dedicated to metal speciation in water, which calculates the distribution of metals among free metal complex with inorganic ligands, complex with dissolved organic carbon and particulate organic carbon, and with different particulate matter like oxides and clay. And this metal speciation model can be combined with river ecosystem model, combining phytoplankton, invertebrates, and fish. So this is an overview of some VERMEER tools that are now available on the website. Thank you for your attention.